Okay, in this video we begin to look at the second method we have for solving a system of equations, and that is the elimination method. So recall, as we said before, with substitution, to solve a system algebraically, we need to find a way to use our two equations to produce a new equation with only one variable. Alright, that is our goal when solving a system algebraically. So we got to find a way to use the two equations to produce a third equation. The elimination method is based on this idea. We're going to add our equations in such a way that one variable cancels out. Alright, so we're going to actually add the two sides of the equations together, combine our like terms, and our goal is that one of the variables will cancel out. To make sure that this actually happens, we have to first make sure the coefficients of the variable we want to cancel out are actually opposites. So if it's a 3x in one equation, we need it to be a negative 3x in the other, so that when they add together, the 3x's cancel out. We'll get an equation with only one variable. So that's going to be the main focus here as we talk about elimination. Okay. So let's consider a system here. This is a system we've solved a couple of times now. X plus y equals 6, x minus y equals 2. So the first thing we notice here in this equation is the y coefficients are actually already opposites of each other. So we can actually go ahead and just add the equations together. When you do that, we'd have x plus x is 2x, y plus negative y, well, they cancel out. They're opposites, so they're gone. So we have 6 plus 2 equals 8, and so we have the equation 2x equals 8. We can then solve by dividing both sides by 2, and we find out x is 4. So now really quickly we know that x has to be 4, just like we always have done now when we did by substitution. Once we've solved one of those equations, we know one of the variables, we can take that answer, plug it back into one of our equations. In this case, let's take the x equals 4 and plug it into the equation x plus y equals 6. When we do that, we put 4 plus y equals 6. We can very easily solve for y and get y equals 2. Okay, so to kind of summarize what we've done, here's what we do when we solve a system by elimination. We first choose a variable to eliminate. Every once in a while, like in this equation, you'll actually have the variables already having opposite coefficients. We'll pick that one. Add the equations. So the first thing is to choose a variable to eliminate. Once we've made that choice, we then multiply either one or both equations by numbers to make the coefficients of that variable opposites. Now, in this example here, we didn't have to do that. We'll see some examples of that in our upcoming videos. Second step is to add the equations, and that eliminates the variable, much like we added our two equations there. And that produces an equation with only one variable, like we had here, 2x equals 8. Okay, so now the remaining steps are the same as substitution. Solve the new equation, and then plug the answer back in to find the other variable. So in the next video, we're actually going to look at this process of using elimination. We'll see using these steps to choose a variable to eliminate, and then how we multiply one or both of our equations to make the coefficients opposites, and then how the rest of this process falls out. We actually have seen now process 2, 3, and 4, because this equation we did here was actually, the coefficients were already opposite, so we've done everything but step 1. So in the video coming up, we'll be looking at some examples of doing that.